All right, guys, this is note card 29, talking about natural logs, or y equals ln of x. Natural log of x. So we talked a little bit about this in note card 28, but the inverse function to natural log is actually the Euler function. So I kind of draw that in there. All right, this is the y equals e to the x function. Those are inverses to each other. Okay, so if you think about this, the limit, as I go further out to the right on the ln of x curve, okay, as x approaches positive infinity, okay, this keeps going up and up and up. It goes up slowly, but it does keep going up. So the limit as x approaches infinity for that function is infinity comma dne. Now, you can't take natural logs of negative numbers, okay? So the limit as x approaches negative infinity, way over here, this curve actually doesn't exist, okay? But let's write in one more here. The limit as x approaches 0 from the right here, if I get closer and closer and closer to 0, this curve keeps going down and down and down. So that's going to be negative infinity comma dne. Okay, because it's going to head down towards negative infinity. We know that negative infinity is not a real number. Okay, so that's why we put the dne at the end. All right, now a couple facts about ln that you have to know. Ln of 1 always equals 0. Okay, and then if you take e and raise it to an ln, those are inverses to each other, so they basically cancel each other out, so you're just left with x. How do you take the derivatives of this function? It's real easy. I just want you to remember this one right here. Okay. The derivative of ln of u is simply the derivative of u, the derivative of the inside, over the inside. So let's see, this should be really straightforward. All right, so let's look at number 1. It says find v prime of t if v of t equals the natural log of t squared plus 3. So this is like the u, so we're going to take the derivative, so to find v prime of t, we're going to take the derivative of the inside, which would just be 2t over itself, the inside, t squared plus 3. That's what this is saying. Take the derivative of the inside, okay, over that thing again. Okay, let's try number 2. It says if y equals 4x times that, find y prime. So if you notice here, this is a product. So there's your first term, there's your second term. So let's use the product rule. Derivative of 4x is 4 times the second, which is ln of 5x to the 4th. Product rule always plus. The first, 4x, times the derivative of this thing. Well, how do I find the derivative of that thing? I'm going to take the derivative of 5x to the 4th, which will be 20x to the 3rd back over 5x to the 4th. Okay. We can simplify it a little bit. 4 ln of 5x to the 4th plus 4x times 20 over 5, simplify to give me 4. X cubed over x to the 4th, there's an x left in the denominator. Okay, this x, which is really in the numerator, cancels that x. Okay, so here you're left with 4 ln 5x to the 4th plus 4 times 4, which is just 16. Or you could factor out 4, and you get ln of 5x to the 4th plus 4. Either one of these answers would be acceptable if you simplified. Let's do number 3 now. I'm going to do that on another sheet of paper. I'm running out of room here. So it says differentiate, which we know means take the derivative. So h of x here equals natural log of tangent of x over 3 pi. And remember, there's an understood 1 in front of that. 3 pi is just a number. It's 3 times 3.14. So I'm going to rewrite h of x as 1 over 3 pi. That's the entire coefficient times ln of tangent of x. Okay. So when I take the derivative, when I differentiate, the coefficient stays. Okay. And how do I take the derivative of this? We take the derivative of the inside. Derivative of tangent of x is secant squared of x over the inside again, which is tangent of x. Okay. So this would be one answer, but that answer might not be there. Let's think about another way we could write that. Okay, what is secant squared? Secant squared is 1 over the cosine squared. Tangent is sine over cosine. So if you want to think about this, with fraction division, we keep the first fraction the same, 1 over cosine squared of x. We change the division bar into multiplication and we flip that. So when that happens, this cosine of x cancels one of the cosine of x's on the bottom. So what we really have here is 1 over 3 pi times 1 over cosine of x times 1 over sine of x. So the answer could be written as 1 over 3 pi times the cosine of x times the sine of x. So the answer might be written like that. Okay. Or the answer could be written a little bit differently. You should know that 1 over cosine is really the same thing as saying secant, and 1 over sine is the same thing as saying cosecant. Okay, so they actually could write the answer as secant of x, cosecant of x, all over 3 pi. And that's probably how if this was a multiple choice question, that's probably how the answer would appear. They'd probably leave it like that. Or 1 over 3 pi secant of x, cosecant of x. They could write it like that too. So one of those 3 methods, one of those 3 answers would probably be there. Most likely it would be this one, if it was multiple choice. Let's look at the next problem. It says, find the slope of the tangent line, not the equation of the tangent line, just the slope, to the graph of y equals 2 times ln of secant of x at x equals pi force, which we should know right away means 45 degrees. Okay. So what is the slope of the tangent line? What I'm really looking for is I'm looking for y prime at this value. That's what I'm trying to find. Find y prime with pi force. Before I can find y prime with pi force, I need to find y prime of x. Well, here's what y is. So let's find y prime. 2 is a coefficient, it stays. How do I find the derivative of natural log of secant? We take the derivative of secant of x, which is just secant of x, tangent of x, over whatever's in the inside, secant of x. Okay, not too bad. That's actually kind of nice because the secant of x's can cancel each other. So the derivative is just 2 times the tangent. Now you might not know what the tangent of 45 degrees is. So you can also write the tangent as the sine over the cosine. So when I would try to find y prime at pi fourths, that would be 2 times the sine of pi fourths over the cosine of pi fourths. Well, what's the sine of 45 degrees? It's root 2 over 2. What's the cosine of 45 degrees? It's root 2 over 2. Okay. So here, this thing right here, root 2 over 2 divided by root 2 over 2, it's the same on the numerator and denominator, so that just turns into a 1, because the tangent of 45 degrees is 1. So my final answer here is simply 2. They're just asking me to figure out the slope. So it's 2. Okay. If they ask me for the equation of the tangent line, then after I got that slope, I know the x value, I would have to plug that x value back into the original function to get the y value. Then I would have my point and slope, and I could write the equation if they ask me for the equation. All right, let's try number 5. Here's number 5. Write an equation for the tangent line to this at x equals 1. Okay. So number 5 here, looking for the equation of the tangent line. It says f of x, here's the original function, negative 2 plus ln of x squared at x equals 1. So if I want the equation of a tangent line, I need 2 things. I need point and I need slope. I know the x value there is 1. I don't know the y value yet, so let's figure that out first. But before we do that, what does slope means? It means derivative at that x value. So I got 2 unknowns I need to figure out in this problem. So let's figure out the point first. F of 1 would be negative 2 plus ln of 1 squared. Okay. Simplifying, that's negative 2 plus ln, 1 squared is 1, and we have to know that natural log of 1 is always 0. So that's negative 2. So the y value there is negative 2. Now, to get the slope, I need to find f prime at 1. So let's first find f prime of x. Okay. Well, here's the original function. Let's find the derivative. Derivative of constant is 0. How do I find the derivative of this? Okay. I'm going to use my ln rule. I'm take the derivative of the inside, which is 2x, back over the inside. So the 0 doesn't really matter. One of these x's cancels one of these x's. So here simply f prime of x is going to equal 2 over x. And if I wanted to find f prime at 1, I'm just going to plug in a 1 right there. So it's 2 over 1, which is going to equal 2. So I know that's 2. As soon as I know both pieces of information, I can write the equation of the tangent line. Y minus negative 2 from right there equals m from right there, 2, x minus 1. Make it look a little bit nicer. So that's y plus 2 equals 2 times x minus 1. So that's one way to write the equation of the tangent line. If that answer is not there, they might have changed it into slope-intercept form. They could have subtracted 2 from both sides. Then if you distribute out 2x minus 2 minus 2, so they could have written the answer like that. Y equals 2x minus 4. So here was the original function. Oops. -2 plus ln of x squared. Just going to zoom standard it. That's what that curve looks like. Is the point 1, -2 on the graph? If I trace, type in -1, or excuse me, if I type in 1, 1, -2, looks like the point's right. If I wanted to draw a tangent line, drawing the tangent line to y1 at an x value of 1, hit enter. Here comes the tangent line. So that's what the calculator shows me what the tangent line should look like, and I think the equation of the tangent line is 2x minus 4. Let's see if that covers that blue line. Yep, looks like it's going right on top. So I do have the correct equation of the tangent line. All right, number 6. It says f of x equals the natural log x plus 4 plus e to the -3x. They want to know what f prime at 0 is. Before I can find this, I got to find f prime of x. Okay. So here's the inside. That's what's going to go in the denominator. X plus 4 plus e to the -3x. And what we put in the numerator is the derivative of that. So derivative of x is just 1. Derivative of that constant is 0. The derivative of this term would be the derivative of that, which is -3, times the whole thing again, e to the -3x. Now you could simplify this if you want, but really all my goal is to find f prime of 0. So to find f prime of 0, everywhere I see an x, I'm just going to plug in 0. So 1 plus a -3 is -3. E, -3 to the -3 times 0 is still 0, over 0 plus 4 plus e to the, if I plug in 0 there, -3 times 0 is 0. What is e to the 0? It's 1. 0 plus 4 is 4, plus e to the 0 again is 1. Okay. So it becomes 1 minus 3 over 4 plus 1 is 5. So to me it looks like the right answer here is -2/5. Be really careful when you're simplifying, okay? Just take your time there. That's actually where you're going to make mistakes. The calculus isn't too hard. It's the arithmetic where students generally make mistakes. Going on to the next page, note card, just more practice here. And you can try some of these. All right, so on the back page, it tells me y equals ln x to the 5th minus 4x, just asking for a derivative. Okay. So whatever's on the inside, that's going to go in the denominator. Okay. And then you can take derivative of that inside, which would be 5x to the 4th minus 4. You can try to do some factoring. Maybe it helps, maybe it doesn't. So in the denominator, I can take out an x power. If I do that, I get x to the 4th minus 4. Doesn't really help, because I can't cancel this and this. They're not exactly the same. So either one of these answers would be fine. Can't go any further though. All right, number 2. Let's see what they're asking for. Trying to find the x value or values where the tangent line is horizontal. So where I have horizontal tangent lines. So if the tangent line's horizontal, you know that horizontal lines have slopes of 0. So that's where y prime equals 0. That's what we're looking for. We're trying to figure out where y prime is 0, or where g prime of x equals 0. Okay. So they actually give me the function itself. They say g of x equals negative x to the 4th power plus e to the 2x. I might want to rewrite g of x to say negative 1/4 x plus e to the 2x. It's going to be a little bit easier to take a derivative. So let's figure out what the derivative is there. G prime of x. The derivative of negative 1/4 x is simply negative 1/4. And the derivative of that thing, we would have an e to the 2x times 2. Okay. So I'm going to have a horizontal tangent line where the derivative equals 0. So now I have to solve that. I'm just looking for the x values. I'm not looking for points, just the x values. So add a 4th to both sides. Okay. How do I get rid of that 2? I divide by 2, or I can multiply by a half. It does the same thing. So now I have e to the 2x equals 1/4 times 1/2 is 1/8. How do I get rid of e? I put ln in front. So now I have 2x equals natural log of 1/8. Okay. And if I wanted to solve for x, I could simply divide by 2. So here, that's natural log of 1/8 divided by 2. That's one way I could write the answer. What about if this was multiple choice and it didn't show up? If you remember some of your log rules, when you have the log of a fraction, you could write that as the subtraction of the 2 logs, the numerator and the denominator. Okay, so this might be an answer presented. Or you should know that ln of 1 is 0. Okay, so it could be written as negative ln of 8 over 2, or you could say negative 1/2 ln of 8. I could write it like that. What about if none of those answers are there? What else could we do? Well, 8 is equal to 2 to the 3rd power. Okay. So it could be written like this. Exponents can be moved in front, so this could be negative 1/2 times 3 ln of 2. Could be written like that. Okay. Or they could take the negative 1/2 times the 3, and they could say negative 3/2 ln of 2. So if you type in any of these things into the calculator, they all will give you the same decimal. Okay. So there's a lot of possible ways you could get, like you might do everything right, and you might think that this is the answer, but if it's multiple choice, that might not show up. So you have to remember your log rules, things that you can do. And as soon as you get an answer that matches one of the answers on the test, that's where you can stop, okay? So any one of those answers would be acceptable. All right. Number 3. It says, find velocity if the position function, which we call s of t, is given by 7 over the square root of t plus natural log of 3t minus 5. So what I would do before I find velocity, I would rewrite the position function. maybe one more time. Write that as 7t to the negative 1/2 power. So now it's in a good spot to take a derivative. We know that the velocity is equal to the derivative of position. So 7 times negative 1/2, that's negative 7/2. Reduce the power by 1, that would be negative 3/2. That's the derivative of this term right here. All right, how do I take the derivatives of natural logs? We know we're going to have a 3t minus 5 in the denominator. What's the derivative of that thing? Well, it's simply 3. So maybe a little bit nicer way to write it is negative 7 over 2 t to the 3/2 power plus 3 over 3t minus 5, or negative 7 over 2 times the square root of t to the 3rd plus 3 over 3t minus 5. That's how I would probably write it. I'd probably write it like that. Okay. Let's try the next one. Number 4 here. Says y equals natural log of x over x. All I'm trying to do is find y prime. So if you think about y prime here, y is a quotient, so I can use quotient rule. Low, d high. How do I find the derivative of that? Well, x would go on the bottom, and what's the derivative of x? It's just 1, so the derivative of ln of x is simply 1 over x. Minus high ln of x, d low, the derivative of x is just 1 all over low squared. Now if you do a little simplifying here, this x cancels that x. So you have 1 minus ln of x, because ln of x times 1 is still ln of x, all over x times another x is x squared. Okay. Very straightforward right there. Now, could you have done that a different way? Yeah, you could have. You could have actually done it this way. You could have rewritten your y as ln of x times x to the negative 1 power, and then you could have used product rule instead of quotient rule. I'm just going to show you it gets you the same answer. All right, so if we're going to use product rule here, we would say derivative of the first. So the derivative of ln of x is 1 over x times the second, always a plus, with the product rule, okay, plus the first times the derivative of the second, so negative 1x to the negative 2. So you have 1 over x. You can rewrite x to the negative 1 as another 1 over x, okay, plus ln of x over 1 basically, times negative 1 over x squared. And if you do all that, 1 times 1 is 1, x times x is x squared. ln of x times negative 1 is negative ln of x. 1 times x squared is x squared. There's already a common denominator. So either way you choose to do it, using the product rule or the quotient rule, you should come out with the same answer. Now if these did not have the same denominator already, then you would have to get a common denominator before you combine. Let's try number 5. Number 5, it says differentiate, which means take the derivative, e to the negative x times ln of 3x squared. So to me that looks like a product, so I'm going to use a product rule. f prime of x, I'm going to take the derivative of that. Okay, so the derivative of that would be e to the negative x itself times the derivative of negative x. Derivative of negative 1x is simply negative 1. Times the second term, okay, plus the first term times the derivative of the second. So a 3x squared would be in the bottom, and the derivative of 3x squared is simply 6x. So I might want to rewrite that to something a little bit nicer. First off, one of these x's cancels one of those x's. 6 divided by 3, I can simplify as 2. In both terms, I have a common factor of e to the negative x. So I could factor that out. Then what do I have left? I have a negative 1 ln of 3x squared plus a 2 over x. So that'd be a nice way to write the answer. Or you could even write e to the negative x as 1 over e to the positive x. So you could write it like that. Or this is really over and understood 1. So I could write it as negative 1 ln of 3x squared plus 2 over x all over e to the x. You can write the answer like that. Or you could even mess around and get a common denominator in the front. You can multiply both of these by x over x. And if you did that, you would have a negative x ln of 3x squared plus 2 over x, all over x, over e to the x. So you could write the answer like this. Or you could even go one step further. And you could say negative x ln of 3x squared plus 2 all over x e to the x. So we would keep the first fraction the same times the reciprocal of e to the x, which is 1 over e to the x. Keep, change, flip, and it would lead you down this path. So any of these answers are acceptable. Now, if it's a multiple choice question, keep working it out until you get an answer that matches. Okay, and even like in this last example, this is a positive, that's a negative. You can rewrite it. You could put the positive term first, the negative term second, and that's fine because this is a plus sign and addition is commutative. So I can just rearrange that. 1 plus 2 is the same thing as 2 plus 1. Okay. A lot of different possible answers that are all equivalent. All right, a few more. This is kind of a long note card, so apologies about that, but it's covered. All right, number 6 is a calculator question. Okay, so we will use it. All right, it says let f be the function given by this really complicated thing. Okay. For what value of x is the slope of the tangent line to f equal to negative 0.4. So what do we know about slope of tangent line to f? That means f prime. So it's for what value of x, so I don't know what x is. I want to figure out where is the derivative equal to negative 0.4 or negative 2/5. And this is a calculator question, so I can use my calculator here. So here's what I'm going to do. Here's how I'm going to do it. Here's the easiest way to do it. You could work out the derivative. Okay, if you want to spend a lot of time working out the derivative, you could. But there's an easier way to do it. Okay? So what I'm going to do in my calculator, I'm going to put the original function into y1. So the original function is natural log of the fraction 3x squared over x minus 5. But I'm not actually going to graph that. There's a way I'm going to turn it off. So if I hover over the equal sign and hit enter, it's going to turn that function off. I'm not going to see it, but it's going to be in there. What I really care about is the derivative function. So if I hit math and go down to option 8, which says numerical derivative, that's what I want a graph of. So I'm going to tell the calculator, take the derivative of what's in y1 and evaluate it for all x values. And I'm just going to zoom standard this. So this graph, what's going to come up in green here, is going to be the derivative graph. Not the original, but the derivative graph. You might ask yourself, why is it starting at an x value of 5? Because if x was anything less than 5, then this denominator would be negative, which would make the whole thing negative. But you're not allowed to take derivatives, or you're not allowed to take logs of negative numbers. So that's why x has to be bigger than 5. That's why the graph starts at an x value of 5. We want to know, where does this derivative have a value of negative 0.4? So going or in another function, let's just put in the line y equals negative 0.4. Or negative 0.4. So here comes that line. I really want to know where those two curves come together. So I can even make my window a little bit different. Let's just look at between y values of negative 1 and positive 1. We're zooming in on that graph a little bit. Here it comes. So there's the derivative graph in green. And here's the horizontal line, negative 4/10. Let's figure out where these intersect. They intersect, I'm just toggling about right there. So I'm going to hit enter again, hit enter again. And it tells me what the intersection is. The x value is 6.404. So this occurs at an x value of 6.404. That's all the question's asking for what value of x. Now here's a way we can verify it. I'll show you a way to verify it. Let's turn off the derivative graph, and let's turn off that negative 0.4 line. Let's turn back on the original function. Let's just go zoom standard. So what's coming up now is going to be the original function. So that's this function right here. Okay. If I did second calculate the derivative, so number 6, at an x value of 6.404, and it tells me up top, calculate the derivative at a point. hit enter, it tells me there that the derivative right there has a slope of negative 0.4. So I know I'm right. A few more examples here. Number 7 says find the instantaneous rate of change at x equals ln of 3 for the function h of x equals x squared over 4 minus e to the 2x. Well, we need to know what this means. Instantaneous rate of change is the derivative at a point. Okay. So derivative of h at this number. I'm trying to find h prime at an x value of ln of 3. So before I can find that, I gotta find h prime of x. So remember, x squared over 4 can be written as 1/4 x squared. So you would take a fourth times 2, that's 2/4. You would reduce the power by 1, minus the derivative of this piece would be 2e to the 2x. So if you wanted to make that look a little bit nicer, instead of writing it as 2/4, you could write it as 1/2. 1/2 x minus 2e to the 2x. Now I want to figure out what h prime at ln of 3 is. So everywhere I see an ln of 3, or everywhere I see an x, I'm going to plug in ln of 3. Simplify if we can. No big deal there. All right. This is a coefficient. I can actually move it to the exponent of that. So I can write this as ln of 3 to the 1/2 power minus 2e. And again, that 2 is a coefficient. I can move it to the exponent there. So 2e raised to the ln of the 3 squared. So what's another way I can write ln of 3 to the 1/2 power? Well, 3 to the 1/2 power means the same thing as the square root of 3. Minus 2. E to the ln cancel, and 3 squared is 9. So this is like saying 2 times 9. 2 times 9 is 18. Oh, so I would probably choose to write my answer like that. All right, so number 8. Number 8 is one of those dreaded piecewise functions. So it gives me a piecewise function. I want to know, is it or is it not differentiable at x equals 1? Because that's the point where it changes. It goes from this part's a parabola, this part's a line. So before it can be differentiable, is it continuous? Is it continuous? I don't know. So does the left limit equal the right limit? So does the limit exist, and does the limit equal the function value? So coming in from the left side, it's x squared plus 1. That's what the function is. Coming in from the right side, it's 2x. What happens when I plug 1 in? If I plug 1 in here, 1 squared is 1, plus another 1 is 2. So the left limit is 2. And coming in from the right side to 1, 2 times 1 is 2. Okay. So here the left limit equals the right limit. Is the function value defined? Yep, the function value there. Function value at 1 would be the same number as this, because the left side. So does 2 equal 2 equal 2? Yeah. So it is continuous. Okay. Now we can see if it's differentiable. Is it differentiable? I don't know. So think about this. If I come in from the left side, what's the derivative of that right there? The derivative of x squared plus 1 is simply 2x. Okay, the derivative of 2x is 2. Now plug in the 1. Okay. So this has to do with the slopes. Okay. If I plug in 1 everywhere I see an x, 2 times 1 is 2. Here there's nowhere to plug in a 1, so that's also 2. So does 2 equal 2 here? Yeah, that works. So it is differentiable. Okay. Because it's continuous, the left limit equals the right limit equals the function value. And it's now, since it's continuous, it could be differentiable or it might not be. The slope approaching 1 coming in from the left is 2. The slope approaching 1 coming in from the right is also 2. So it is differentiable. Number 9 says find y prime if y equals the ln of the ln of x. Okay, so how am I going to find y prime? Ln of something, okay, ln of u, remember what it says. If I want to find the derivative of ln of u, all I do is u prime over u. Okay. So here the u is another ln of x. Okay. The u is the ln of x, so ln of x will go on the bottom. And what's the derivative of ln of x? It's 1 over x. So if I wanted to write this a little bit nicer, this is like saying 1 over x divided by ln of x over 1. We can keep, change, flip. And we can say the answer is 1 over x times ln of x. Number 10, all I want to know is the slope of the tangent line. So that means derivative. So all I want to find here is f prime at 1 at this x value. Before I can find f prime at 1, I need to find f prime of x. So it's some e. So when I take the derivative of e to the u, I get another e to the u times u prime. So what's the derivative of x squared? It's 2x. So that's the general equation for the derivative function. Now to find f prime at 1, everywhere I see an x, I'm going to plug in 1. So 1 squared is 1. 2 times 1 is 2. So e to the first, it's just e. And e times 2, we usually write it as 2e. Number 11, I'm trying to simplify a limit. So I'll tell you right now, if I plug in 6 here and 6 here and 6 here and try to simplify it, I'm going to get something that says 0 over 0. Okay. So let's try some factoring. If I factor out a 2, from the numerator, I get x minus 6. And if I factor this quadratic, I get x minus 6 times x minus 3. Well, that's nice because these x minus 6's cancel each other. Because remember, it says I'm approaching 6, not necessarily what I get when I plug in 6. Now, if you try to plug in 6 to what's remaining, okay, you would get 2 over 6 minus 3, which is 3, so 2/3. You would get 2/3. Number 12, another review question. They want to know what the derivative of arctan of 3x squared is. So I'm going to start by writing y equals arctan of 3x squared. So to make this a little bit nicer, how do I get rid of arctan, which means tan minus 1? I would put a tan in front of both sides. That would get these to knock each other out. Then I would draw in a right triangle. We're going to call this angle y. And what do you know about tangent? Tangent is like the opposite over the adjacent. So if this is my angle y, the opposite side is 3x squared, the adjacent side is 1. Now, I'm probably going to need to know what the hypotenuse is eventually. So let's just start by calling it a. So you should know that 1 squared plus 3x squared squared has to equal a squared by the Pythagorean theorem. If you actually multiply this out, 3 squared is 9. X squared squared is x to the 4th. That equals a squared. So if I wanted to figure out a, I would have to take the square root of both sides. So a would equal the square root of 1 plus 9x to the 4th. So that's square root 1 plus 9x to the 4th. So there's our picture. Now, how do I take the derivative of this? I have to use implicit differentiation. So tangent of y, derivative of tan is secant squared. We leave the inside alone. Times the derivative of the inside, which we call dy dx. Over here, I have a 3x squared, so the derivative of that would simply be 6x. So to figure out dy dx, okay, I would divide both sides by secant squared of y. But what is going to be the secant of y? Let's figure out what the secant is. Remember that the secant of y is 1 over the cosine of y. So the secant squared of y, if I square both of these, okay, we would get a 1 squared, which is still 1 over the cosine squared of y. So what this actually turns out being, if you divide by secant squared, that's the same thing as multiplying times the cosine squared. You want to think about it, it's the same thing. But what's the cosine of y? Cosine of y is adjacent 1 over the hypotenuse. 1 plus 9x to the 4th. So if you square this, you would have to square that side. So what's that going to be? It's going to be 6x times, if you square this, let's think about it, you would get a 1 if you square it. And if you square a square root, it's going to knock that out. It's going to knock out the square root. So my final answer here is going to be 6x over 1 plus 9x to the 4th. Or you could simply write that as 6x over 1 plus 3x squared quantity squared. If you just remember the formula, you know that it would be u prime over 1 plus u squared. That's the formula, if you remembered that. Derivative of 3x squared, simply 6x, 1 plus this thing squared. So there's the formula for it. All right, number 13, last question here. It says, simplify this. Now, this looks really, really complicated, but it's actually just about you recognizing the definition of derivative. So this part right here is the f of x. F of x simply equals 3 times the ln of 5x squared. And what this entire thing represents is f prime of x. So all we really want to find in here is we just want to figure out what the derivative is. Well, if you know what the function is and you remember what the rules are, it shouldn't be that hard. So this is a coefficient, it stays. Whenever I want to take the derivative of an ln, whatever I'm taking the ln of, that goes in the bottom. Then in the top, you just take the derivative of that. So the derivative of 5x squared is 10x. You can simplify a little bit. 10 over 5 becomes a 2. This x knocks out one of those x's. So 3 times 2 is 6. So if we simplified that out, it would give us the same thing as 6 over x. All right, so that completes this guided problems on this note card. Your packet tonight, it's real straightforward. It's a single free response question just doing parts A and B. So it tells you that a velocity is this. Okay. It's asking you to find the acceleration. You should know that acceleration is the derivative of velocity. I want to know all the times when the particle changes directions. Find all the times when the particle changes directions. So just try to work it out at the bottom here. So first, figure out when it's at rest, then use a number line analysis to help you answer the question. Also asking you, when is it traveling to the left? So answer both of those parts of that question. All right, that's going to do it for this note card.